I'll be preparing what I just said. Because actually, I've been trying to, from just now until now, I've been trying to tell you all what I've been trying to say since when we're doing practical. I think I repeat that quite a few times. I think I'll be printing something for you all for the practical, but it's only a guide now. At the end of the day, make sure you have enough time to plot the graph. For physics, it's graph. Then, of course, chem is to finish the observation plus the conclusion. That's all. Okay. Is there any topics here you want me to look through? We have about another 40 minutes plus or 50 minutes. Which question you want me to go through? Is there any question you want me to go through? Or is there any topics that you think you have some issues on? So you want me to go through? Yes? Type if you want, you can type. Then I see how we can put inside again. Okay. Anyone? No, nothing. For physics, you all have anything you ask me with regards to physics? Displacement. Okay, displacement is on, how should I say? Displacement is you have to look at the reactivity series. So if you're looking at displacement, first you must memorize the displacement. Oh, you're talking about displacement for observation. What do you mean by, can you be more clear? What do you mean by observation? Is it by, are you talking about structured questions or you're talking about the practical? Which one? Displacement is actually the reactivity series, like how to tell. In terms of practical, if you're going still back on practical, it's actually you will see something precipitation coming out or something solid at the bottom. But actually for chemistry, not that it's not possible. Displacement is actually more for in combined science is more on practical. It's on combined science, right? It's usually more for structured question in theory only. You don't usually see it for you don't see it actually in practical. Not much. Okay, so but of course the rules still apply. What you do, I give you one very simple example. I give you a simple example. Like you look at zinc and you look at iron. Who is more high in the reactivity series? Zinc and let's say zinc and iron. Who is more reactive? Zinc, right? So you notice if you put like zinc, a piece of zinc inside an iron 2 solution, you notice that zinc being more reactive than the iron, right? It will dissolve first because being more reactive, right? It will dissolve into a solution to take over the female component, which is the anion component. Then the iron will be displaced outside. Then it will coat around it. This one is actually not really for pure. Yes, you notice they actually have an experiment to show that one displacement, which means they put a piece of like zinc inside an iron 2 solution. Then you notice that the whole thing will cover itself up. Or another one is silver, like silver, and you put maybe iron also can, or you put iron slower, and you take maybe zinc is one of those, or magnesium even very fast. You put magnesium inside silver nitrate. Magnesium inside silver nitrate. You'll notice that the silver will coat around the magnesium. Okay, will coat around the magnesium. So then you will create something like a crystal-like thing, something very hairy metallic things that will stick around it. That's all. And then the color depending on if it's like silver, right, you won't believe silver is white color, that's polished one. But if you put in like magnesium inside the silver nitrate, it's actually brown, grayish gray color for metal things that will form at the side. For displacement practical, so far no, I don't see much of it. Maybe there is, but it's under observation. But they won't ask you for the rationale. So far, they have not asked you for rationale yet. I've not seen it. Because there's so many things to test. If you look at the, like for example, the test of because they are more focused on getting the cations and the anions, these two things. By itself, if you want to ask me, like test of the cation, right, and anions. Right? For the white precipitate, you got the tick cross, correct? Calcium, zinc, aluminium, lead. 3 of them, actually 3 out of the 4, we got 3. Then the other one is for the anions. There are 5 possible anions they can test you. From what? Sulfate lah, chloride lah, iodide is out lah. Of course, you got the nitrate, then followed by the carbonate. So many of them, at least got 4. So it's 8 of them to test. So, and then there is still things like, for example, heating, correct? And there's also, if you put in OAR, there's quite a few bunch of things already, more than 50 marks. Because it must consistently come up to one big picture. Because they have to combine it under a picture. And then you talk about test of gases. And that one is also another one, pungent, odorless, and the one is also another 2 marks. If they test you for odors, they won't test you for pungent. More than enough, if you ask me, really, more than enough. If you ask the traditional question, more than enough. So displacement actually got no place to put inside. Okay, and also displacement is also not found inside. In theory, yes. In theory, yes, but in practical, no. I don't see the very prominent application of it. At most, it's only observation. You put, like for example, you put zinc inside silver nitrate. What do you see? Then you just say, oh, silvery grayish solid being deposited at the site. So things like that. Very, very observation based one. So you won't have a theory. Or if not, at most, they only ask you why is it so. But even then, they have to tell you the solution, which is stupid because in the first place, they need you to find what is the solid. They won't tell you, right? So it's like, I think it's like a very low chance they ask. Okay. In terms of practical, in terms of structure, right? Yes, I think there is. In terms of practical, yes. In terms of structure, there is. Okay, there is actually questions based on it. So if you want, you can actually refer to it. I don't know whether you have or not. Let me see. To find the last year's one, see whether we have anyone based on the. You look at, if you want an MCQ, maybe you look at MCQ 2019, right, question 14. Yeah. 2014. Yeah. Yes, 14. Let's look at 2019, right, question 14. Have you turned to that page? Do you have the 10 series review? Do you have the 10 series review? Can you please turn to 2019 MCQ question 14? 14 and 15 is all on displacement. This 2 is on displacement. Okay. So the first one is on austenite, is at the bottom of group 7 in the periodic table. Which row describe the properties of austenite? The one it talks about what? Color, confirm is black. It won't be brown because iodine is already black. Austenite is lower, right? So it will be black. So answer is between A to C. State, of course, is solid. It won't be liquid because already iodine is crystal, MR is quite high, austenite even higher, so confirm is solid. So it will lie between B and C. The other one is what? Reaction with potassium bromide. Okay, bromine is what? Lower, is higher in the reactivity series. Higher because group 7, right? Okay, for group 7, the displacement is what? The wider is the radius, right? Means you're lower down the group 7. What happened? You're getting further and further from the nucleus. It's harder for you to attract the last electron into the outermost shell. So you form an ions harder and harder. It gets more and more harder to actually form ion. So you notice that bromine is actually stronger, right? So actually answer is no reaction. So answer is B for oil. Answer is no reaction. Okay, that is the application. They won't ask you for what you see. If you ask me in terms of the color change, no. Practical, there's no. Okay, so this one for displacement, I think you would like to look at question 14. This one is under group properties. Then the other one is question 15. Reactions with 4. Are you okay? Are you okay? Reaction with 4 metals as shown as 2019 MCQ question 15. Oh yeah, by the way, MCQ you all must do, right? You all know that, right? MCQ, okay, MCQ is the last few paper, okay, which means your structure will come first, followed by MCQ. So if you can also argue, Mr. Lee, we got time, okay, I'll leave it to you. Okay, but technically, I recommend MCQ is a very quick way to actually see which topic you are still strong or you are weak. Okay, because it's a 1 mark question, so it actually gives you a quick idea whether you know or don't know. Because the concept, although it's 1 mark, right, it's not one step. Sometimes it's multiple steps just to get 1 mark. Just like this one, 3 things. It's actually testing you 3 knowledge just to get 1 mark. So if you ask me, it's actually a bit harder, but then you can also say, I can don't guess, I make a guess, right? Oh, correct. This one I saw the Thailand one, how to cheat. Well, provided you have someone that like that. I don't know you all got see the movie. Okay, I didn't. I just download illegal. Then I watch. Wow, the girl really. Well, how will you know? Yeah. But anyway, hard to cheat. Don't think about cheating. That's why question 15. The reaction with the four metals are shown. Cold water, steam, and dilute acid. I think I told you right. Steam and dilute acid is actually almost the same one. So they tell you that W with cold water is gentle, steam is rigorous, and rigorous for dilute acid because these two are the same one. Okay. So Z is what? Rigorous, violent, and explosion. So if you compare, right, Z should be the most reactive, right? Because explosion, oh. So looking at it, Z should be the first one. So the answer is D. This one quite fast. D. Okay, because this one is by reacting with acid. Oh yeah, by the way, this one, if you ask me, displacement, you might as well study this. This is very important. I still remember. I think I got go through with you all the line, right, between steam, between steam and I think zinc and magnesium. If I'm not wrong, zinc and magnesium, there's a slight difference in the reaction one. You have to memorize because you don't memorize this question cannot do one. Under the displacement one. Okay, you need to know the reaction of the various metals with steam and with acid. And where is the borderline? Aluminium, totally no one. Why? Why aluminium no? Why aluminium? You look at aluminium. Aluminium I put there is a special case because aluminium got coating. Okay, and the coating is very interesting for aluminium. I must stress this again. The coating is once you remove, you can sandpaper it. You sandpaper the oxide away, the aluminium oxide away. So this question I started already. It's actually D because from here, right, Z is explosive. Explosive means it's the most reactive one. Okay, the only one explosion is this one, right? With the acid. Then the Y of course is no reaction, of course it's the weakest one. So that's why you know answer is D for dot. Okay, for reaction. So you must know the how they react. The whole table. In short, is like how you know that well for that topic. You write the notes out, which is you write the table, you draw a table, and you can fill in all the parts. Then you're okay already. Means you can actually say with confidence. I know some of you may say that Mr. You reading only Please science is really, if it sounds easy, it looks like it's reading, right? But in actual fact, right, it's actually forcing you to write on notes. Yeah, it's actually forcing you to write on notes. If you look very closely, almost all the answers, you compile all these answers, you compile all you know, right? From 1 year or 2 years, you compile all these, you can write your own notes. You can almost write your own notes out already. That is what I'm trying to get at now. Okay, you all should be able to write the notes. Almost like you can. If I tell you, say I ask you this, you must tell me that. You ask you this, you must tell me that. To be able to tell me that, right, means you must possess the information in your head. Yeah, it's like I think I told you, right, Xiao Ding Dang and the Doraemon, right, he got this book, eat already, the bread book, eat, and then the thing get inside the head. And the thing is you cannot forget. Of course, you can claim that Mr. Lee, I got small memory, or it's like a bottle that leaks, right? Never mind, every day put water in. Really, there's no other solution. Yeah, there is really no other solution. I also don't have a good solution because for this to do well for science, you must memorize. Okay, even for me, when I teach you, you think I use what? I also use memory. You think I use what? So you have to also memorize. So you to reach from where you don't have, right, to what you have, right, you need to memorize. And what better way to memorize is you take a piece of paper and you write the formula out yourself. You write the whole notes out yourself, especially like this one, the reactivity series one. I tell you, I react with acid, react with water, cold water, steam, and acid. And here you write the potassium, sodium, PSC, MaCl, that one, potassium, sodium, potassium, calcium, magnesium, that one. Right? Potassium, sodium, calcium, magnesium, aluminium, lead. Write down order. Then you tell me where it cuts the line. And you tell me why this one is who will react explosive, very violent or not violent. You can draw the whole table out by yourself. It means you understand. Yeah. Generally, it's like that. Okay, you have problem doing that topic, right? It's because you cannot memorize the topic. That's my take. Even for students, like I tell you my experience. I teach the Sec 1 maths. The 1T miss cannot. You know that I tell them so area of circle is what pi r square. Then repeating, cannot one. I told you the only way that you can remember is you write pi r square 50 times. Take a piece of paper, write 50 times. You write You may say it's very boring, but it's like that one because you need to memorize the formula, then you can apply because I found that they cannot memorize the area of circle. No, so some of them I got some issue one. For example, when I was in primary school, I never learned. It's not in secondary school, then don't want. You cannot always live in your primary school. You must jump, correct? So what better way is to write along? So I recommend if you don't want to revise, wait, how do you study? Write notes. Means you choose one topic, you choose one topic and write the whole notes. Like I give you an example, ionic and covalent. You write the table. You know the table I wrote on my notes. You see whether you can write the whole thing out yourself. If you can write, means you're successful. Means that topic you can secure that one. Yeah, it's like that. You have to write your note. You have to write your own notes. Okay, at the end of the day, you find that my notes is useless. Means you reach it. You're there. You say, Mr. I don't need your notes. That should be it. But so far, nobody taught me yet. Very dangerous. This one, because it's when the more you know, the less you need. At the end of the day, you can, I'm still your notes useless one. Because everything I should know, I know. I don't know. That should be the idea. But don't worry, okay? Don't worry. Okay, take time. Now you've got how long? Still got time. Not much, but still got time. Still got time. I tell you, memorize. Start to memorize. Okay, start to memorize. Okay, then. So the activity I talked about it already. Okay, let's look at the structure. Okay, let's look at structure. Properties of nickel. Okay, let's look at 2019 question 8. Okay, have you turn to 2019 structure question 8? Okay. Have you turned to the question already? I hope you turned to the question. It says that nickel, right? This one 2019 question 8. Nickel has a physical property similar to that to most metals. It's between iron and lead in the reactivity series. Very interesting. This is also one type of way. They will tell you something that is not inside the reactivity series. Okay, I must share with you the reactivity series is not exhaustive. It means it doesn't list all the metals. It only listed a few common ones. Okay, less than 20. Okay, altogether, how many elements are there in the whole world? More than hundreds. More than 100. You only list 10 plus only. So it's actually a fraction of it. Tip of the iceberg. So, state 2 physical properties of nickel. So, what do you think is that question asking you? State 2 physical property. This one is what? They didn't say chemical. Actually, the keyword is not 2. The keyword is physical. Correct? State 2 physical. Emphasize 2. It says you don't know what is 2. Physical is the one that you don't know. Correct? What is physical? Ductile, malleability. So remember, ductile, able to pull into the wire. Ductile. Malleable means able to bend many times. One example is like aluminum foil. Aluminum. When you make airplane, why aluminum? Why airplane made of aluminum? How come you don't use iron? Okay, 2 reasons. One is because aluminum is very malleable. Iron, not usually. Iron, if you don't believe it, you take your chair, the one that you go to school, always that table, you go and bend 10 times, you still haven't break. Okay, cannot bend. It's not as bendable. Okay, it's not as malleable as the aluminum. Aluminum is softer. Okay, it's very interesting. I share with you. It's interesting one because I was reading some excavation for China one. Very interesting. They say that they found they found a metal sword. So it was trying to find out. Then they found out that metal sword. What's so interesting about the metal sword is they're able to find it's an alloy. Okay, it's an alloy. Okay, which means that they managed. They found out that particular metal sword in at least 1,000 plus years ago, China was able to infuse carbon into iron. They found that those weapons they're able to, because you see when you extract iron, because when you have metal going to iron age, right, from stone age to iron age, your metals, your instrument becomes harder, right? You can do more things. You can dig, can dig deeper. You can actually grind. You can actually make more structure. Your structure can be more stronger. And that's why they say iron age, bronze age, iron age. All this comes in. Okay, iron they managed to fuse carbonate, which is like today mild steel. Mild steel is used for make car. Yeah, they're able to infuse. So which means you compare to that sword, compared to other at the same time, if you compare to those pure iron one, it's supposed to be harder, but the sword was actually highly rusted because of the mild steel. The technology is not there one. Okay, because doesn't have a coating. So you notice iron when you touch water, it will go into rusting stage. And rusting, why is it very badly done? Is because when it rusts, right, the iron oxide, which is the rust, right, actually becomes more puffier, becomes expand. become larger. So usually, if your iron oxide is actually very packed, just like aluminium, it's very tightly packed, right? The underneath layer of the aluminium will not be further oxidized. But iron become puffy, the structure become chung. So there are more holes. So the holes will absorb more water, then the underneath iron will keep on rusting. So that's why the whole piece of iron become rusted. The iron sword actually was rusted. You were still able to see, because I think deep underground, so you can still see that the layer of the many like kueh lapis, the iron become many layers. Means the iron person, to make it stronger, right, they actually fold the iron many times. Now he fold, then flatten it, then flatten, like kueh lapis, do many times until it becomes a piece of iron which is supposed to be very thick and condensed, a very strong and very compact iron. Okay, very interesting. And then they also found certain sword from the excavation site from China thousands of years ago. It doesn't rust one. It doesn't rust one. And they found a technology. Wow, very interesting. They were able to make you see swords, samurai sword, very interesting because inside got some design, right? They say that they were able to make a repeated pattern inside. But yet when you touch nothing one, you touch the skin, it's like there's no curve one. Yet the sword itself can see pattern one. Interesting. So they couldn't understand how the ancient people did it. So that was also quite so that the iron that they play with is actually malleable. Those very malleable ones means can fold many times, fold many times and then bend it. That's why it's important. So these are some of the physical property. Of course, you can also say high melting point, boiling point. You can also use able to conduct electricity also can, because these are physical property. So for question 8A, name any of the two malleable, always 2 marks only. Okay. So can you give more? Answer is yes, but no marks will be given. Only the first 2 will be given. And do you need to explain? Technically, no, because when they say state, they never say explain. So you can just write malleable and ductile. Technically, you should be able to get an answer because these are keywords. Next one, part 2. In a reaction between nickel and another chemical, a gas is being formed. Describe how you test a gas to find out it's hydrogen or it's oxygen. Very easy. This one is only tell you that it's another gas, but you don't know. So how to test for hydrogen? How to test for hydrogen? They only give 1 mark. How to test for hydrogen? Lighted spleen, right? Correct? And pop sound will be here, correct? And then oxygen, glowing spleen and lights. Like that only, 2 marks. Okay? Like that only. Then the other part is part B. Part B is on your, part B, C is on your, I think, extract. Part B is on your separation technique. Because one is a gas and one is a solid. You read, further read. So only the first part is this one. Physical property, that's all. I'm trying to find the separation. Yeah, like that only. Another one. Real reaction is important, if you ask me. Displacement, I'm trying to find any more displacement. 2019 don't have displacement. So it may come out. Seems like it doesn't have much question on displacement. Yeah, don't have it. Yeah, there's only a bit on the group properties. Yeah, so may not have. Let's do at 2018. Can you do at 2018? Can we all turn to 2018? Okay. A very good gauge is if you want to know what is coming out for this year, right? You can do at 2018. Yeah, because 19 is like what comes out for 19 usually don't repeat. Usually they don't repeat. But like for example, if they ask a certain topic, right? Like you see they're deficient in a certain year, right? You will come back again in the next year. Because it's like they cannot be the whole, not every year ask the same. Okay, they will try to ask. One reason is because, like for example, if a particular question, 2000, like this year, last year they did very well. This year they won't ask one because they want to test so many things to test. Why must you test the same thing? And also, O-level set the question like 2-3 years in advance one. Okay, they accept 2-3 years. So they don't. You imagine the checker for the paper. They say, how come this year you ask that question? Then that next year, how come you don't ask the same question, same type? So usually they will vary. So looking at the trend, right? Technically, this question doesn't have for 2019. This one should have. So I'm trying to find 18 have. 18. Can you find 18? 2018. 18. Don't have. Speed of reaction. Speed of reaction every year have. Speed of reaction every year have. Also don't have. Speed of reaction don't have the displacement for 2018. Can you all find it? Is there? Don't have. Acid and bases, yes. Salt also. they talk about salt preparation. That's why you see 2018 have salt preparation, then the 2019 don't have. Yeah, don't have. You'll notice that 2018 question 9. Question 9 is on salt preparation. It's a 3 question choose 2. Okay. Oh yeah, talking about this one. 3 question choose 2. Maybe because of the common last topic, right? The common last topic issues. Maybe out of the 3 questions you choose 2. 2 questions choose 2, which means there won't be a third question. Maybe. Maybe. Because this is the buffer, which means maybe that 1 year, maybe this year, if they are not going to change anything, right, they delete away 1 question from it, which is the organic one. So I'm not very sure. Okay, they didn't say it. Okay. Also at 2017, I'm trying to find the displacement. You're quite right. Displacement don't have it. Yeah, displacement. See your reaction. You see your reaction. All the 3 years have. If you ask me, see your reaction. It's a small part. It's not maybe not a big part. Yes, turn to 2017. Yes. 2017 questions 9B. 9B. Have you turned to it? Can you turn to it? 2017 question 9B. 9B. It's only 1 part only, 2 marks only. They say that zinc can be extracted from the oxide by using carbon, but boron is extracted from the oxide by using magnesium. Suggest why magnesium, but not carbon, is used to extract boron from boron oxide. This one is like reactivity series. More like a reactivity series. You can also use displacement to explain this question. Have you all turned to that page already? 2017, question 9B. Have you turned to that question? Have you turned to that question? Okay, this one, right? Suggest why magnesium but not carbon is used. So between, you see, zinc can be extracted by using carbon. Zinc can be extracted by using carbon. Zinc can be extracted by using, which means zinc oxide plus carbon to give you zinc plus carbon dioxide gas. Of course, you have to balance it. Okay, that's why you have to balance it. But boron, right? Boron, I think it is group 2. Is it? Boron is it group 2? Is it group 2, boron? Is it group 2? Is boron group 2? Boron, is it group 2? No, it's group 1. So it's boron oxide, right? Then plus you must add what? Magnesium. They say that it's extracted by using magnesium. Then you must use magnesium to give you magnesium oxide plus boron. Okay? Alright. Then they ask you why. Why is it like that? Why magnesium but not boron? Okay. Why magnesium, not carbon, is used to extract boron? Why? Why is this so? Why carbon can be used to extract? This one you can actually use the reactivity. So actually, how many items are there? There are actually 4 items. So actually, you can say that the first one is because the reactivity of the carbon is higher than the reactivity of the zinc. Okay, therefore, you can go through a displacement. This is actually a pure displacement reaction, where the carbon will displace the oxide. Displacement means they would snatch away the component, just like I told you, the chair in a room, right? A chair in a room, which is the oxide. In this case, the chair is oxide. So the carbon will take over the oxide, right, and displace the zinc out. Okay, solid zinc will become, and then carbon dioxide will be taken away now. Okay, so this one is the reactivity of the carbon is greater than the reactivity of the zinc. This is for case 1. For case 2, right, you'll notice this what happened. Boron, right? Okay, boron, right? Actually, the reactivity of boron is actually less than the reactivity of magnesium, which means magnesium is higher. And also, this one also tells you what? Magnesium, right? The reactivity of the magnesium, right, is also higher than the reactivity of carbon, right? It's also higher than the reactivity of carbon. And you also notice because boron cannot use carbon, right? Realize that if you combine these two, right, for part 2, actually you combine, it's actually reactivity of the magnesium is the first one, right? greater than the reactivity of the boron, and the boron is actually reactivity greater than the carbon. So you can actually conclude that carbon is actually lower reactivity compared to the 3. Okay. Can you understand? So this is actually due to you just use reactivity to explain chemistry. Okay. Nothing else. There's no other reason, because you can only explain in terms of the reactivity only. Yeah. Nothing else. But not carbon. So why is it 2 marks? It's because you have to explain the reactivity of zinc. Then you can conclude. Or if you don't want to explain the zinc, never mind. You can still conclude this, because this one is you have to talk about the reactivity of the magnesium greater than boron, and then boron, right, is actually greater than carbon. That's why you cannot use carbon. You put carbon there, it's just that you put for 1,000 years, there's no reaction one. Okay, no reaction one. Why? Because it's actually lower in the reactivity. Lower in the reactivity means nothing will happen one. Just like, for example, Lee Kuan Yew sits on the chair. Lee Hsien Loong stand there for 10 years. Lee Kuan Yew also won't stand up one. Correct? Because why? He too big. He cannot stand unless he move on, correct? Or unless he doesn't want it, but not possible. Usually they hold on to it, hold on to a chair until they are being displaced. So that is the closest that displacement can go. Can? It's okay? It's okay? But it looks like the reactivity came out in 17, then after that, long time never come out. You may want to suspect that it may come out, but I really don't know. Okay? Because it's hard to explain reactivity, because for displacement, it's usually I suspect it's actually they will test you whether the in between one, like for example, in terms of like acid with zinc and magnesium one, or steam with the zinc and magnesium one. Usually it's that one. Because that one has more things, because they actually test you specifically to the part who is within the reactivity. It's actually testing you whether you know the whole sequence, the reaction. So you do that one, you need to memorize. Okay, if not, it will be this, like that only. This is the furthest they can ask in terms of reactivity. So they will tell you a set of experiments and say why this thing doesn't occur, or why this thing is like that. Oh, is it okay? Can? Class, can I ask what are some of the things that you need me to prepare, so that when I see you on Tuesday, because Thursday is your practical, so is there, other than the help for the like a list like that, or some of the experimental conclusion and some of the precaution to take, plus what things to take note, is there other things you want me to prepare for you all? Nothing sounds like a good one. Sounds like a good sounds like you all don't ask me, it's good. Is it? Any more? Rate of reaction. I was quite surprised that you all don't ask me rate of reaction, because rate of reaction is one of the hot ones. Almost every year comes out. Okay, and of course another one is your mole. Mole also comes out. Moles also come out every year. The mole concept. Okay, rate of reaction is quite hot. Sounds simple, but it's actually very it's very hot. Every year comes out. Because I told you that Amon loves it. They love the rate of reaction. I don't know why. Which I thought was quite simple, but I think that Amon loves it. That's why the Cambridge came out asking the mole concept. Okay, see, for mole concept, it's not I don't want to do. I can go through, but there's this part that you know about the limiting reagent, that one. I only talk about the structure one. MCQ one, you want me to talk about MCQ? For the MCQ one for mole, because the MCQ there's another one, the limiting one. They are all the same because it's set by another uncle one. The uncle is only just 1 mark. So mole concept, I will only do, if you want, I will prepare the, what is this? I'll do a bit more on the traditional way, which is the mass comparison method. And the second one is the direct proportion method. Like for example, 2 moles per dm cube, right? 2 moles per dm cube. If I got 40 centimeter cube of solution, how many moles do I have? And how many grams do I have? Okay, or like for example, 1 mole will give you 24 dm cube of gas. If I got 0.5 mole, how many dm cube of gas will I get? This is the new type one. This is the new type one. Then the traditional one is like, for example, they give you an equation. They say 1 kg of like they give you 1 kg of that material will produce how many kg of that? So that is the part about more concept, which they ask in structure. But if you ask me limiting, and you ask me about CV over CV, concentration over volume, that one, concentration times volume, then over concentration of volume, that one is only MCQ. Will never come on in structure one. You go and check, last 10 years never come on. Only MCQ. Okay? Don't ask me why. That one is the uncle, he is stupid one. He don't care O or don't O one. Okay? So more, if you want, I do it then. I think it will benefit more people. Okay? Here, if I go through, wow, one big part again. So this one, more I'll prepare. Whether rate of reaction needs to draw a diagram for, and also for the more I settle, and this one, because more quite large. And I think also a lot of people want to hear more about it. So for the MCQ, if you see the MCQ like concentration times volume, that one, plus limiting one, if you see you really don't know, ignore it. Really. I think we've gone through the last round. And if I go through that again, I may confuse more people, because I think now is not the time to confuse. Now is the time to actually reaffirm, confirm things, and make sure that things are running. That's why I say the best way is actually you close the book and you write your notes. You got nothing to do. You say basically, I really don't know which topic I want. Now I tell you something, you choose the one that I take, right? You choose one of the topic, right? Okay? Then you take a piece of paper, right? To write the whole thing out. So what do you think is a table? Like ionic covalent, that one, you write the whole table out. You see reactivity series, I quickly write the PSC, MAZT, LCM, SG, that one. And then you find out where is it about steam, where is it? For reaction with cold water, steam, and acid, where is the line drawn? Extraction is using what? You write that one out. If you can write, right, means more or less you understand the concept there already. Then the next part will be focusing on the application. Okay, you cannot apply if you don't have knowledge on. Cannot be on. Impossible one. Okay, it's impossible. That's why you notice that your O-level question, there are some questions that is based on knowledge one. A knowledge-based question, which means that they will test you whether you know this, you know that. Like physics, what is the definition of this? What's the definition of why? Because if you don't know how to apply, you can't apply. So your application can only come when there's a basic. If you don't have the first floor, how to build second floor, cannot be. You need to build the first floor, which is your memory work one. So people who struggle in topics, right, is because they cannot memorize. So you just memorize can. I believe I really believe. Just like my T21 telling me, area or circle, I don't know how to do area or circle. Circle I skip. He says it, he told me, a circle I skip. Any shape with circle I skip. Then I found it's because he cannot memorize the formula pi r square. Okay, so you have to memorize. I told him no choice because the school is not going to give you. I said you go to N level, they're also not going to give it to you, pi r square, so you need to know. He said, but Mr. I take foundation. I was in primary school. Yeah. Then last year you also not high, and then now last year in primary school and now you're in secondary school. How to compare, right? So I have to find a way to memorize. Okay, that is my take. Okay, if you really don't know what to do, right, I recommend take out. You think you weak in the topic, right? Take a fresh piece of paper out. Then you write. Cannot write, right? Never mind. Look at my notes. Then you say, this one. You look already, you close it, then you rewrite. Yeah, it's like cheating, but it's like that one. Really, it's like that one. Can more? I think you all still got some, but more. The marks is only 4, 5. Can do. Confirm count on this one. Confirm count. But I will do the part that confirm count for structured. MCQ one, I will. If you want, I touch a bit but you cannot ignore because I'm not joking. That one pure chem I also take 1 or 2 weeks. Some of them also at the end when they first learn also a lot of hard one. Why like that? Those too many things. So you can focus on the traditional, the more mass comparison, and the other one is the proportion one. Can already. Okay. Okay, I answer the visual one. Whether the rate of reaction need to draw diagram. Yes, you need to draw diagram. This one for the rate of reaction. I give you an example 2018. You look at 2000 for basal one. You look at 2018 for rate of reaction. 2018 question 10. Can you turn to 2018 question 10? Have you got some time? 2018 question 10. Just a bit of joke. You know which fairy tale princess is the sick? Is always the sickest, which means most diseased princess in the whole of the fairy tale. You know what I'm talking about. Which fairy tale princess has the most sickness? It's always sick one. It's the worst sickness. has the worst sickness amongst all the princesses? I do not mean the graph. I mean like the experiment setup. Huh? Experiment setup. Experiment setup. Experiment setup. Okay. Answering Basil's question with regards to whether we need to do, you know, the this one, the what is this one? The gas stream. You still remember? Because for speed of reaction, is the best way is actually to see whether the gas collected. So you need to know the gas stream setup like that. Okay, you must learn how to draw. You must learn how to draw. Whether it comes out, that's another thing. This is a conical flask. The conical flask, then the acid. Like that. So remember this one, the conical flask, and then you take your stopwatch, then you time what is the volume of gas produced. Now this one I think last time they like to ask, okay, but over the years they don't seem to ask that one because I think they want to focus on the interpretation of the graph. This experiment setup is, if they do ask, you can just say what you can draw the diagram. You draw this diagram. You draw the diagram with the gas stream and the cylinder and the conical flask. With the acid here, then you label like acid solid everything. Gas stream. You put in all the labels and you say, then I teach you set up as shown. That's what I have. Set up as shown. If you don't write like that, take the conical flask, put the acid in, put the solid, put the rubber stopper, put a delivery tube. Wow, I don't know how many words you're going to write, but you just draw this, then you label all the different parts, right? Then write the first question, set up as shown. Then the second part is what? Take a stopwatch, right? Time the volume of gas produced at fixed interval. Second, memory. In short, it's memory. Use a stopwatch. Take the volume measure or take the volume of gas produced at various time intervals. Also can at various intervals. Plot the graph. Then the answer is like that. But you compare. If you ask me, I don't think they want to ask that. Because if you look at 2018, the same year, 2018, right, part 3, 10B part 3, describe how you use your graph to determine the speed of reaction at 2 minutes. I think I'll ask that because I want to talk about, like, let's say the graph you draw like that, right? Then you versus like that, right? And draw these two. Then I ask you, how do you determine the two speed? Then you will link to what? This is more thinking question, right? Mine, I will ask you, how do you know, like, between reaction A and reaction B, which one has a faster reaction? Our answer is A. Why? Because this one is time and this is volume, correct? Okay. Time means that you see A takes a shorter time because it hits the maximum limit, correct? The maximum volume. Whereas B takes longer time, correct? That's one thing. Second one also what? The gradient, right? The gradient, right? Is like maths, right? The gradient of the graph is actually steeper compared to the gradient of B. So the speed, right? Which means that the steeper the graph, faster reaction. Well, more description. If you ask me more conclusion, then you take this. This one, you write a lot. It's just on, on what you need to do, what you need. So in the light of like O level, right, requesting students to think more on thinking question, right, I will ask this and this. This is more tedious, like, set up like this, put that, put this, put that. But if you talk about second one, you have to interpret. You after you draw the graph, you draw yourself. Then you say which graph is faster, right? On the basis, you see, you read the question. Describe how you use your graph in part B, part 2 to determine the speed of action. The rate of action. Okay, so thinking in terms of like thinking questions, right, I would recommend to focus more on this. Okay, then this one, of course, it goes back to your speed time reaction, the speed distance speed time, link back to the gradient one. That's why that part is actually important. It's like kinematics, It's like maths, like kinematics. You need to understand that graph interpretation is also one of the skills required for science. Okay, I do agree. Like hey, my maths poor. Wow, this one maths and science are together, right? You know, right? You remember, I don't know whether you all got remember, Sir Isaac Newton, he's one of his famous speech, he likes to make this, what he says, I stand on the shoulder of a giant, right, and I can see very far. He like to give this stupid analogy. Why? Leh? Who is that giant? You know who is that giant? His field of study is maths. Then you know who is that giant? It's maths. So he says that by looking at calculus, he created a whole thing called calculus, right? Standing on calculus, right, I can see further. It's correct, because using calculus like integration, differentiation, he's able to see further. He's able to see, oh, why the universe like that? Why sun moves like this? Why is it elliptical shape? How come it's not circular? Why is the shape like that? How distance moves? So very interesting one. Okay. So same thing as I also tell you there is some component of mathematics on. Okay. That's why I disagree to a certain extent. Why some people say use words and explain cannot. No, that's wrong. But there'll be some part I think using maths to explain. That's why I always like to tell you like Mr. Lee is half the weight of an elephant versus Mr. Lee is double the elephant. You remember this one? I keep on telling you about this one. There is a reason because I think you must possess certain basic skill like ratio. No, this is actually ratio. So you must know that what does this ratio mean? It's half when the ratio is 2, right? So if you can arrange your equation to this, that's why you notice that a lot of the science question like physics one or even the chemistry, those physics one, they ask you about this one. Ask you to compare. I talk about pressure, right? If you look at the pressure question, it's also like that one. They force you to actually do it this way. Of course, you can argue just like for example, primary school method. You say, why is it that you use a spoon to open a Milo tin versus you use a coin to open the Milo tin? Why is it more difficult to open using a coin? Of course, you can use the primary school answer. Or further from the pivot, less effort. Closer to the pivot, more effort. So it's like I don't know. It's like closer to Lee Kuan Yew, clever. Further from Lee Kuan Yew, less clever. I don't know. Like there is no reasoning. It's like it's like this phenomenon you didn't know, man. So sometimes compared to this type of answers, able to change it to a ratio format, compared to just saying statements, I would say that the argument is stronger, but nothing wrong because the answer also can accept it. Because that was the beauty of it. You are able to accept a lower end answer also can. Because that's the idea about exam, you see. As long as you give us the concept, I don't care whether you give me a strong answer or weak answer. Okay, as long as the answer is there, I'll give it to you. As long as the answer is there, okay, you may not be able to derive. You can just tell me the answer. Roughly the answer is around here. As long as it makes sense, okay, you get 1 mark. So because there's no determination to say that you don't need to prove to me. Just say it's like that. I won't give you marks. Marks will still be allocated, but I thought if you can go one more step further to explain like that, you'll be stronger. Your proof will be stronger. Yeah, that's my take. Okay, but coming in terms of like, if you say this is very difficult. My teacher also last time never say that. Why you say like this? Also can not that it's wrong. That's why I say I must put a disclaimer. The proof is compared to this and this. You must understand as a marker who marks across the whole of Singapore. Right? If you have students who write like that and write like that, you know where you stand. That's my take. Personally, my take. Because I've seen before. I've invigilated other schools before. Interesting one. You see, Cat High. I give one example. Cat High, 8 classes of pure. One. The PSLE 2-4 something they combine. You think the 2-4 something is everyday play games one? Also quite strong one. Yeah. There's also one of my colleague, my ex-colleague, who went to Hai Sing. He was telling me his class, on average, almost everybody got A1, but 3 or 5 students got A2. He was called to a principal office. The principal asked him why these 5 students got A2. My goodness, I pull my hair. What? Like that also can. Wow. The competition is stiff. I would say it's just that we live in our own world. We don't know unless you go to them. So after a few years he left there. He said he cannot take it. He said, wow, he says the A2 not up to him. It's not that. Sometimes it's like that. What can I say? So sometimes when I come to my current school, although it's a bit weaker, I tell them okay, it's okay. At least my principal didn't ask me, how all your students fail. Not that all my students fail, but I said, huh, how come these students, because they can understand? Sometimes you need a bit of understanding, like where you come from. Okay, same thing. Your support must from your family, from people around you. Okay, so I give you my assurance also. Touch wood, touch wood. If you this year don't make it, okay, I tell you again, if this year really don't make it, you have my number. You just ask, Mr. Lee, are you teaching next year science? If you want to hear the same jokes, hear the same stupid things, take the same notes, right? You call and say, Mr. Lee, you're teaching me there. You want to say it, I'm okay on. You want to say it, I'm okay on. Okay, but this is I hope you all don't use it. Clear ones out, can, because this is that's one topic you should be able to clear. Can? So on Tuesday, I'll be giving you all the paper on the practical. I also talk about more concept. It's okay? These two? Anything more? Then we'll talk more on that day. Is it okay? And I thank you very much all for listening. I think you all have been quite a very good audience. I keep on talking. I don't know you all got it or not. I hope you get it. Okay, for students who are don't know what to do, I tell you already, please just take one topic, you try to write out the notes. And then you compare my notes. Hey, what's the difference? Did I miss out this? Oh, I miss out this and you remember this. Okay, you miss out that, you just remember, then okay, that's it. Okay, if not, you rewrite again. That's why you can rewrite. Oh, I miss out this, I miss out that. Choose any of the tick topic. I tick for you the topic, right? And it's not for fun, it's actually for you to tick already. You close the book. Okay, I can then write the whole notes out. I'm not asking you to write the whole thing, but at least the main gist, outline. Like for example, ionic covalent, you can draw for me the table, whether they are what type of bonding, lattice, giant lattice, why is it the high melting boiling point, able to conduct electricity, and the right whole thing out. If you're able to write, right, cool already, you can get it already. Physics is a bit more complex, because that one is, that's why I tell you already, I also told you something, I tell you one word, one keyword, like refraction. Oh, you must tell me, got critical angle in total internal refraction, simple and what the refraction from critical angle then to the total internal refraction, everything. They must tell me all the condition, how to find, how you think. Then you're there. Or I give you this one, lenses. I tell you this two word lenses only. You must give me beyond 2F, at 2F, between F and 2F, at F and between 0 and F. And all the different conditions, like, okay, this one is a camera, that one is a projector, that one is a like a photostatic machine projector, then the other one is your spotlight, then to magnifying glass. Everything must come. You tell me, I'll just a virtual inverse. That's it. That's why I say, if you can do this, right, you no need to submit. You don't need to summon my brain. No need. You already have already. I'm already with you already. Okay. Because if I'm with you, I also have to memorize this. Okay. And you summon me, also got problem. My handwriting very bad. I think over the years, my handwriting getting bad to us. Yeah. So I think you summon me, also got problem. Okay. And then I tell you, I also too heavy. If my soul come to your body, so I think you also die. You cannot walk. Too heavy. Nowadays, I only got one soul. I don't think I got multiple. That's why they say, wow, God can exist anywhere. I don't think so. Maybe he can. I can't. One person summon me, the other person can summon me. Okay? Can? Joke. These are all jokes. Okay? Can? So I'll see you on Tuesday. Can? I'll see you on Tuesday. I've taken your attendance already. Can? That's all. Can? Can I see you on Tuesday? You say that for prayer, we need to know 4 topics. What is the last one? QA. Oxidizing and reducing agent. You missed out the oxidizing and reducing agent. Memorize the oxidizing and reducing agent. Which one is oxidizing and which one is reducing? Okay? Okay? Yeah. But as I say, that one may not come out. Because last year come out already. May not come out. Okay? May most come out one part only. Then focus more on the OARA. Or QA, the test of the tick cross that one. Okay? Focus more on that one. Okay? Can? We'll talk more on Tuesday. Okay? That's all. Thank you very much. You all can just log off. I will just submit. Okay? Can? That's all. See you on Tuesday. Then I'll prepare the things for you all. Okay, then do get through and then ask me things. Okay? That's all. Just say bye and that's all. Okay, Ken? Thank you everyone. Okay, I have to take the things. Okay, Ken? No question here. Yeah. What question is it saying? Can ask. If not, you want to ask on Tuesday now. Is it okay? Ken? See. It's okay? It's a bit late now. Go have your dinner. Okay, I will have to submit some things to the HQ. Okay? Thank you very much. Bye-bye.